3, the values of a and b that make the sum of the squares of the residues a minimum can be calculated using the formula. B is given by sxy over sxx, and a is given by the mean of y minus b multiplied by the mean of x. This one very important. We are going to use it moving forward. And for each point, as you see in this diagram, for each point on a scatter diagram, for example, point A or point B, this is point A, point B, you can express y in terms of x as y, probably we have y1, this is y1 because we are talking about x1, this is y1. Point A has coordinate x1, y1, so y1 can be expressed as is equals to a plus b x1 plus e1. bx1 will only give us up to that point because that is the point where our straight line is. So plus e1 is called the residue, where e is the vertical distance from the line of best fit, and this is shown in the diagram that the value of y1 at this particular point A is a plus bx1, which gets us up to there, plus e1, which now gets to where A is. Of course, we have had that E is the vertical distance from the line of best fit, and this is shown in the diagram. And of course, now E is the residue. This is called the residue. The residue. The bold line down there on page 137, the line that minimizes the sum of the squares of the residue is called the least squares regression line. That is to say, of course, the sigma E squared is a minimum. The line is called the regression line of y on x. And ultimately, the equation of the regression line of y on x is, of course, given by y is equals to a plus bx, where b you can see that is our b, and where our a is given by that. So we will not be able to, we will not have problems actually finding our value of a and finding our value of b, because how to get there is shown here. And of course, you can remember in the previous topic, we understood so much about sxy, sxx, and sx or syy. So this is now what you're going to use in example 4 below. All right.